Okay, dear students, so there is a question on your screen, and we just did the concept of calorimetry, and let us now apply that. So, in these kind of questions, these questions are very popular in paper too, so they're very important. An ice cube of mass 25 grams and the temperature negative 10 degrees centigrade is dropped into a glass of water, mass 300 grams, and temperature 20 degrees centigrade. Calculate the final temperature. So, first of all, I must tell you that in these kind of questions, we use the principle of calorimetry. Time and again, it is repeated. What is the principle of calorimetry? The heat lost by the hot body will be equal to the heat gained by the cold body or the cold solution, whatever. So, the heat lost is equal to heat gain, and we do not consider that the heat is given to the environment or there are some losses of energy taking place there. We are not considering them. So heat lost by the hot body. So the ice cube of mass 25 gram. So let's say there is this ice cube which is 25 gram and the temperature is negative 10 degrees centigrade. It is dropped into water. So the water is 300 grams and the temperature is 20 degrees C. Obviously 300 gram is too much. It's a very big mass and comparative to 25 grams. So obviously the ice will melt. Calculate the final temperature. So ice should be melting and everything will become liquid. Specific heat is given everywhere. So we will see that. So this is the liquid here. So the heat lost by water will be equal to heat gained by water. In these kind of questions, what we do, we draw a graph, and the graph is actually temperature versus time, like this. So this you can say this is temperature of the vessel or the fluid total, and this is time which is there. So there is ice here. So I can assume any temperature here. So I can take this to be 0 degrees centigrade, let's say. So the temperature for the ice is negative 10. So let us start at this point, which is negative 10 degrees C. So ice will first increase its temperature and it will become 0 degree. This is called sensible heating of ice. Sensible heating of ice because temperature is increasing. We are giving heat to it and there is a corresponding increase in temperature. Once it becomes ice at 0 degree, it starts melting and it melts into water at 0 degree. In the phase change, as we have already seen, there is no change in temperature. So temperature has not changed. So ice at 0 degree C is converted into water at 0 degree C. Now this water, because every the complete ice has melted into water, now the process of sensible heating starts again, and it will again rise to certain temperature. So let us say there was water which was already maintained at 20 degrees C. So this temperature is, let's say, 20 degrees. This was water. So water will be losing some heat, and so the temperature of the water will go down. And let's say at the end of this, like equilibrium, this is T temperature which was maintained. So at this point, this is the equilibrium point. So from this point, the water is losing its heat and it is the temperature is falling there, and as per the ice is concerned, it is increasing its temperature to temperature T. So this is the map or the diagram or the complete story, whatever is happening here. So now we can clearly see that from this point to this point, let me call this point as A and this point as B, C, D, and E, let's say. So it means the heat lost by the water in the glass from A to B is the heat gained by ice in converting or in moving from E to B, E to D, then D to C, then C to B. So there are three different occasions when this heat is absorbed in three different manners. Point number one is sensible heating of ice. D to C is the latent heating or the latent heat that will be released now. And from C to B is this again the sensible heating of water. So these three heats have been given and all the heat is coming from A to B region only. So let us now concentrate on numeric part of this now. Now what to do? So we will say that what is the heat lost by the liquid by let's say 200 grams, 300 grams of water. So we would be using mc delta t because it is clearly the case of sensible heating or sensible cooling. So mass is 200 grams, which will be converted into kgs. Specific heat of water is 4200 joule, that we know. So it will be used in SI unit. So you can't put the value with kilojoules. You have to convert it into joule every time. This into delta T. Delta T is a variable. We don't know the temperature of the point B, but this we know 20 degrees centigrade. Now, as per delta T is concerned, you can even use the centigrade values or the Celsius values, need not to convert it into Kelvin. For delta T, there is no difference. But if you're talking about one particular temperature, at that time you got to change it into Kelvin. But as of now, we need not to do it because we are concerned with delta T, the change in temperature. So it is 20 minus T. This is 20 minus T. This is the heat which is lost from A to B. This is the heat that is lost there. Now this heat is given to ice. So heat gained. How are you going to write heat gained? So first of all, the sensible heating. Let us say mc delta T for ice first. Then we would be concentrating on the latent heat. Then we will concentrate on the sensible heat again for the liquid that was created. So mc delta T. So mass of the ice is 25 grams. Now specific heat of ice. So specific heat capacity of ice is given to be 2200 joule per kg Kelvin. Okay, 2200 joule per kg Kelvin. 2.2. I think it is correct data. Into delta T. So delta T will be 0 minus minus 10. So it will become 0 plus 10. Now the ice has melted into D. So what is happening from D to C? The latent heat. So again the mass is 25 grams. The latent heat here, this formula, this value given is wrong. Actually this is 334 kilojoules. So 1000 has to be multiplied. So I just remember this value, that is why I know it is wrong. It is 10 to the power 3 here. M into L. Plus we will be again using mc delta T only. So this is M. But now the specific heat of water again, because now the ice has melted and it has become water. So we would be using 4200 into the change in temperature, which is here the temperature was 0 and here the temperature is T. So I will write it as T minus 0. In these kind of questions, it is always higher minus lower temperature. It is not final minus initial. So at this point, you can clearly see I have not written it to be T minus 20. I have written 20 minus T. It is higher minus initial, lesser. Higher value minus lesser value, not the final minus initial. So be careful at that time. Okay. Now we are going to substitute these values here. Once we substitute, we would be getting the correct answer. So I'm not calculating this thing here because it will be taking otherwise quite a time. So I'm not doing that, but this is how you do it. And you would be having t as a variable here on the left hand side of the equation and another t on the right hand side of the equation. So that is going to be a big equation. You will solve it arithmetically and accordingly you can get the answer. This is it.